Day class. This is Mr. Adewale, your mathematics teacher. We are back again to our mathematics class, and today we are considering another interesting topic, and that is solving indicial equations. Solving equations that have to do with indices, applying laws of indices. So let's quickly consider some example. I know you know some of the laws of indices, so we're going to apply some of those laws to solve some equation, mathematical equations. So can we do that now? So we have some questions here. Solving indicial equations. So solve the following indicial equations. The first one, 25 raised to power 5x equals 625. When you hear equation, that means there is equal to sign in between. That's the difference between expression and equation. These are equations. So the first one, let's go to the solution now. The first one, we solve it together. So solution. Solving it, the first one now. We have it 25 raised to power 5x equals 625. 25 raised to power 5x equals 625. Alright. So with this now, when you are solving indicial equation, this is the base here. This is the exponent. 25 is the base. The exponent is 5 raised to power x. It's 5x. That's the exponent. This is the base. We also call it the power. So somehow, at the other hand, you look at the figure given. There should be something that you can have a base like the base at the left hand side. You could have something. You can form a base from the figure given like the base at the other side. So what does that mean? All right, 625, if you check, is 25 times 25. That's 25 raised to power 2, and you see 25 is the base here now. So there's something that connects the two together. So solving it now, so that's 25 raised to power 5x. So you can change this to 25 raised to power 2, because 25 raised to power 2 means 25 in two places. It means 25 times 25. 25 raised to power 2 is not 25 times 2. It means 25 times 25. And that is 625. So how did we get to know this? Look at the base at the other side. There should be something. If not the exact base, there should be something they have that connects with each other. So with this now, so you can cancel the base out. So 25 here, then you cancel this. So you have 5x will be equals to 2. Why will you do that? When you have common base, it can cancel out now like that. So if 5x equals 2, then you divide both sides. You divide both sides. Both sides by the coefficient of x. That's 5. 5x over 5 will be 2 over 5. Then x is 2 over 5. Again, let's quickly go over it. 25 raised to power 5x equals 625. Then the base here is 25. Now, considering a base here, look at the other end. There should be something. You can change the figure. You should be able to change it to a form in which the base will be the same like the one at the other side, or something that is a factor of the one at the other side. But since we have 25 squared to be 625, you put it there, then the base will cancel. Since they are the same, then you equate the powers. And you divide both sides by the coefficient of the alphabet, and then you get your answer. I hope that is clear. So the second one now, the second question, 1 over 2 raised to the power of x equals 8. All right. If you want to solve this, it's still like the other one. Look at this. I can change 1 over 2 in indices. It's same thing as 2 raised to power minus 1. Now, I know you understand the law. You know the laws of indices. So this is negative index law. So 1 over 2 is same thing as 2 raised to power minus 1. Then raised to power x equals 8. So when you expand this now, this will be 2 minus times x, that's minus x, will be 8. Now 8 2, this is the base here is 2, the power is minus x. 8 2 can be changed. 8 is 4 times 2, and 4 is 2 times 2. So 8 is 2 in 3 places. 2 times 2 times 2 gives 8. So you can say 2 raised to power minus x will be 2 raised to power 3. Then you cancel the base since they are the same now. Minus x will be 3. You multiply both sides by minus 1. Multiply both sides by minus 1, and so x will be minus 3. x will be equals to minus 3. Again, check it again. Half 1 over 2 is the same thing as 2 raised to the power minus 1. That's the negative index law in indices. I know you know the law. So then the power of x equals 8. 8 again can be rewritten as 2 raised to the power 3. That is not 2 times 3. That's 2 raised to the power 3. And that is 2 multiplied by 2 multiplied by 2. 2 in 3 places. Then the bases that are the same can cancel out. And then you get the final answer. And x will be minus 3. I hope that is clear. So the third one now. The third question. 3 bracket 3 raised to power x will be 27. Now, please do not make the mistake of expanding this bracket. You cannot say 3, this one will be 3 times. No, because this one is 3 raised to power x. All right. So, what do we do? The first thing, let's divide both sides by this 3 here. Divide both sides by 3. Then you have 3 bracket 3 raised to power x. All over 3 will be 27 all over 3. This one cancels 3. So you have 3 raised to power x equals 3 here 1, 3 here 9 equals 9. Now, alright, 3, this is a base now. And 9 again can be changed to this. They have common base now. This one will cancel. Then x will be 2. I hope this again is straightforward. Please do not make, like I said, do not make a mistake of expanding this bracket, like, because this is 3 raised to power, this is 3. So you cannot call this one. You can't say 3 times 3 is 9 raised to power. No. You will be breaking mathematical law that way. Alright. I hope this is clear to you. The next one, the fourth question, we have 0.25 raised to power x plus 1 will be 16. So how do we solve this? 0.25 raised to power x plus 1 equals 16. Alright. And mind you, I've told you, you must find a way to have common base at the left and the right hand side. Alright, this is a decimal now. You find a way of change, you change it to fraction. How do you change it to fraction? Now, converting a decimal to fraction, this point becomes 1. So you have it as 25. The point becomes 1. Then how many figure here? 1, 2. Then that will be 2, 0. Raised to power x plus 1 will be 16. So you can divide 25 here 1. 25 in 104. That's 1 over 4 raised to power x plus 1 will still be 16. So, like I said the other time, 1 over 4 is 4 raised to power minus 1. That's in indices. That's negative index law. Raised to power x plus 1 will be 16 is 4 raised to power 2. You can see they're already having common base. So this is 4 raised to power, let's expand bracket, minus times x, that's minus x minus 1 will be 4 raised to power 2. So this one can cut this. You have x minus 1 minus x minus 1 will be 2. So minus x will be 2. When you take to the other side, that means plus 1. And that gives 3. So let me complete it here. So minus x equals 3. So you multiply both sides by minus 1. Say x will be what? Minus 3. That's our answer. I hope this is clear. Check it again. 0.25. You change it to fraction. The point becomes 1. The 0 is inconsequential. 0.1, 2 figures. That's why 2 zeros. Then you divide it. You have 1 over 4. And then this also is 4 raised to power down. And that's 4 times 4. That's 4 in 2 places. That's why that's 16. Then you open the bracket. That's power product law. Minus 1 times x, that's minus x, minus 1 times plus 1, that's minus 1. So you cut the bases, the base here and the other one, then the power are equated. You collect like times. Minus 1 go to here becomes plus 1, minus x equals 2 plus 1, 3, and x will invariably be minus 3. I hope that is clear. God bless you. The fifth one now. 9 raised to power x minus 1 will be 27 raised to power x plus 1. This is another indicial equation. You can see indices. I've told you indicial equations are equations that you will need to employ the laws of indices in solving them. Alright, how do we do this one? Look for common base. This is 9, this is 27. The bases are not the same. You have to find a way of doing that. Alright, 9 is 3 raised to power 2 bracket x plus minus 1 equated to 27 is 3 in 3 place, 3 times 3 times 3 bracket x plus 1. If you like, you can cut it now. You can cut the basis now. That's the basis. Then you have equate the powers. Equal 3 bracket x plus 1. Expand the brackets, this 2x minus 2 with 3x plus 3. Then you collect the like terms. Collect the like terms. How do you do that? Now you have 2x now. Bring this minus 3x equals, you have plus 3 here, 3. Bring this one, that's plus 2. Minus 2 becomes plus 2. This is minus x equals 5. And you multiply through by minus 1, and x will be what? Minus 5. I hope that is also clear. The last question here, that's 9 raised to power 2x minus 1 equals 81 raised to power x minus 2 divided by 3 raised to power x. Alright, you still find a common base for all of them. Then you proceed. Alright, this is 3 raised to power 2 bracket 2x minus 1 equals 84. 81 is 3 raised to power 4. Because 81 is 9 times 9 and 9 is 3 raised to power 2. That means 81 is 3 raised to power 4 bracket. And I've said 3 raised to power 4 does not mean 3 times 4. It means 3 in 4 places. 3 times 3, 9 times 3, 27 times 3, 81. Bracket x minus 2 divided by 3 raised to power x. You would then see they all have common basis. But at this point, you will also be breaking mathematical rule to divide it now. No. You bring it to an equation, a straight line equation, before you can divide the basis. You will narrow the basis down to 2. You bring them to 2. They are still 3 now. All right. How do we do that? This 3 raised to power, let's expand. This is 4x minus 2 will be equal to this 3 raised to power 4 times x, 4x minus 8. But this is x. X divided by x. Division turns to minus in indices, minus x. Common base, so you can bring it up. All right. So at this point, if you like, you can divide the bases now. Then you have 4x minus 2 equals 4x minus 8 minus x. All right, so 4x minus 2 equals 4x minus x minus 8. I just brought this one here. You have 4x minus 2 equals 3x minus 8. You can still now collect like terms. Collect like terms. So you have 4x. When this is coming here, it becomes minus 3x will be equal to minus x. Then you come here plus 2. X invariably will be minus 6. I hope this is clear to you. So you will agree with me that indicial equations are very simple. So you do well to solve some other questions there. Get more questions and leave your answers at the comment section. God bless you. We are there to offer you the best. So stay tuned for next content, and please do well to subscribe and press the notification button and also share with your friends. God bless you.